ይስጥልኝ እንዴት ከረማችሁ? አይ ሆፕ ሁላችሁም ራሳችሁን ከኮሮና ቫይረስ እየጠበቃችሁ ነው። እንግዲህ ነገን ለማየት ደግሞ ዛሬን መጠንቀቅ ይኖርብናል። እንግዲህ ዛሬ እኔና እናንተን ያገናኘን ጉዳይ ደግሞ ያው እንደሚታወቀው ተማሪዎች ሀገራችን በተከሰተው የኮቪድ ወረርሽኝ ምክንያት ትምህርት ተዘግቶ በቤታችሁ ትገኛላችሁ። ከተወሰነ ጊዜያት በኋላ ደግሞ ሀገር አቀፍ ፈተና እንደሚጠብቃችሁ ይታወቃል። በመሆኑም ለብሔራዊ ፈተና እንዲረዳችሁ እኔ የሚያቅሜን ያህል የዜግነት ግዴታዬን መወጣት ስላለብኝ የ12ኛ ክፍል ማትስ ነው በቀላሉ ማንም ተማሪ በሚረዳው መልኩ ስቴፕ ባይ ስቴፕ በሆነ ወይ ቪዲዮዎችንና ጥያቄዎችን በዩቲዩብ ገጽ ይለቀላችኋለሁ። እናንተም የዩቲዩብ ቻናሌን ላይክ እና ሰብስክራይብ በማድረግ በየጊዜው የሚወጡ ለኢንትራንስ የሚያግዟችሁን ትምህርቶችና ጥያቄዎች ማግኘት ትችላላችሁ። Don't forget, as the saying goes, the only way to learn mathematics is to do mathematics, so keep practicing. ያው ከምሰጣችሁ በተጨማሪ ተወሰነ መጽሐፉንም እያያችሁ ፕራክቲስ አድርጉ። Okay, let us shift to our business. So after completing this chapter, you will be able to understand the concept of limit and find out the limit of sequence of numbers, determine the limit of a given function, and determine continuity of a function over a given interval, apply the concept of limit to solve a real-life mathematical problem, as well as develop a suitable ground for dealing with differential and integral calculus. እንዴት ከረማችሁ? upper bound and lower bounds here. The definition of upper bound and lower bound states that let a(n) be a sequence and small m and capital M be an element of real number. Then the first condition is capital M is said to be an upper bound of the sequence a(n) if capital M is greater than or equals to ai for all ai an element of the sequence a(n). And the second condition is small m is said to be a lower bound of the sequence a(n) if small m is less than or equals to all ai's for all ai's an element of the sequence a(n). And the last thing is the sequence is said to be bounded if it has an upper bound that is bounded above, and if it has a lower bound that is bounded below. Therefore, in order to be a sequence to be bounded, it has to be bounded above and bounded below. And don't forget that here a sequence a(n) is bounded if and only if there exists k greater than 0, says that the absolute value of a(n) is less than or equals to k for all n an element of natural number. Example 1, consider the sequence 1 over 4n, and we are going to find sum of the upper bound and the lower bound of this sequence. And in order to find the sum of the upper and the lower bounds of this sequence, first we need to find the terms of this sequence. In order to do that, we need to substitute the value of n starting from n is equals to 1, because since n is an element of natural number, we start from n is equals to 1. Therefore, for n is equals to 1, the value of our sequence will be 1 over 4 times 1, which is 1 over 4, and for n is equals to 2, the sequence will be 1 over 4 times 2, which is 1 over 8, and again for n is equals to 3, 1 over 4 times 3 will be 1 over 12, again for n is equals to 4, 1 over 4 times 4 is 1 over 16, again for n is equals to 5, that will be 1 over 4 times 5, which is 1 over 20. And as you can see from the terms of this sequence that are, we have 1/4, 1/8, 1/16, 1/12, 1/16, 1/20, and so on. As the value of n is getting larger and larger, the sequential value becomes decreasing and it approaches to 0, but not equals to 0. Therefore, this sequence is bounded between the two numbers, that is between 1/4 and 0. Therefore, we can say that 1/4 is less than or equals to 1/4 and is less than 0. Therefore, in order to select the upper bound, the first thing is you need to compare these two numbers. The greater is 1/4. Therefore, take any number which is greater or equals to 1/4. እዚህ ጋር ሁለቱን ታወዳድራላችሁ። ከዛ በኋላ 1/4 ከ0 ይበልጣል። ስለዚህ ከ1/4 እና ከዛ በላይ ያሉ ቁጥሮች ሴት ኦፍ አፐር ባውንድ እንላቸዋለን ማለት ነው። ስለዚህ upper bound will be 1/4 and any number that is greater than 1/4 can be. Therefore, you can take 2, 3, 100 and so on. Again, to select the lower bound, take 0 as a reference and any number which is less than or equals to 0 will be the set of lower bound. Therefore, the set of lower bound includes 0 and any number which is less than 0. For example, -1 can be -3, -5, -75, and so on. Therefore, these are the set of upper and lower bound. But from the set of upper bound, the greatest will be the greatest. From the set of lower bound, the greatest will be the greatest lower bound. See this one. እዚህ ጋር ምንድነው ከሎወር ባውንድ ብለን ከዘረዘርናቸው ቁጥሮች ግሬተስቱን ደግሞ ምን እንለዋለን? ግሬተስት ሎወር ባውንድ ባጭሩ GLB እንላለን። ስለዚህ for our case, our greatest lower bound will be 0, and when we come to the greatest lower bound ደግሞ the least upper bound ደግሞ ስንፈልግ ነው የምናደርገው ከአፐር ባውንዶች ውስጥ ትንሹ least upper bound ነው። ቅድምም ብለናል 1/4 እና ከዛ በላይ አፐር ባውንዶች መሆን ይችላሉ አለ። ከአፐር ባውንድ ብለን ከዘርዘርናቸው ደግሞ ትንሹ ማለት ነው 1/4 ነው ማለት ነው። ስለዚህ least upper bound 1/4 እንላለን። ስለዚህ እዚህ ጋር ኮንፊውዝ እንዳትሆኑ least upper bound-ን ሰሌክት ስታደርጉ መጀመሪያ አፐር ባውንዱ ጋር ትሄዳላችሁ። ከዘረዘራችኋቸው ባውንደሪው ማለት ነው። በሌላ አባባል ከአፐር ባውንዶቹ ዝርዝር ውስጥ ትንሹ least upper bound ይሆናል። ከሎወር ባውንዶቹ ዝርዝር ውስጥ ደግሞ ትልቁ greatest lower bound ይሆናል ማለት ነው። ስለዚህ ኤግዛምፕሎችን እየወሰዳችሁ ቴስት እያደረጋችሁ ፕራክቲስ አድርጉት። Example 2, consider the sequence 3n minus 2/n, and we need to find the set of upper bound and the set of lower bound, and also we are required to find the least upper bound and the greatest lower bound. And in order to do that, let us first find some of the terms of this sequence, and let us substitute, since n is an element of natural number, let us substitute the smallest value of n, that is for n is equals to 1. Therefore, for n is equals to 1, it will be 3 times 1 minus 2 over 1, and this is 3 minus 2, that is 1, 1 over 1 is 1, and for n is equals to 2, it will be 3 times 2 minus 2 over 2, and this will be 6 minus 2 over 2, which is 6 minus 2 is 4, 4 over 2 is 2, and again for n is equals to 3, it will be 3 times 3 minus 2 over 3, and this will be 9 minus 2 is 7 over 3, and again for n is equals to 4, for n is equals to 4, it will be 3 times 4 minus 2 over 4, this will be 12 minus 2 is 10, 10 over 4, and and let us take a number that is larger than a big number. For example, let us take for n is equals to 10. This will be 3 times 10 minus 2 over 10. This will be 13 minus 2, which is 28 over 10, and this will be around 2.8, and again for n is equals to 100, it will be 3 times 100 minus 2 over 10, and this number is around 300 minus 2, which is 298 over 100, and 298 over 100, and this will be 2.98. As you can see from this, as the value of n is getting larger and larger, our values that are our values, as you can see from here, our values are very closer to 3. Therefore, as you can see from this, this sequence is bounded between 1 and 3. Therefore, this is 1 is less than or equals to 3n minus 2 over n is less than 3. That means the numbers are very closer to 3, but not possibly equal to 3. Therefore, in order to select the upper bound, first what we are going to see is we have to compare these two numbers. ስለዚህ ከሁለቱ ቁጥሮች ደግሞ ትልቁ ማን ነው? 3 ነው። ስለዚህ 3 እና ከ3 በላይ የሆኑ ሴት ኦፍ አፐር ባውንድ ይሆናሉ ማለት ነው። ስለዚህ አፐር ባውንዳችን ማንን ይዛል? 3 any number greater than 3 can be 6 18 ማለት እንችላለን 33 or any ሎወር ባውንዳችን ደግሞ ስንመርጥ ማንን ነው የምናየው? 1 እና ከዛ በታች ያሉ ማንኛውም ቁጥሮች። ስለዚህ ሎወር ባውንዳችን ማን ይሆናል ማለት ነው? 1 and any number which is less than 1. ለምሳሌ 0 መሆን ይችላል፣ -1 መሆን ይችላል፣ -17 -27, any number. And when we come to the greatest lower bound ምን ብለናል? ከሎወር ባውንዶቹ ትልቁ ደግሞ 1 ነው። ስለዚህ greatest lower boundaችን 1 ይሆናል ማለት ነው። when we come to least upper boundaችን ጋር ስንመጣ ደግሞ ከአፐር ባውንዳችን ትንሹ ማን ነው? 3 ነው። ስለዚህ least upper boundaችን 3 ይሆናል ማለት ነው። ስለዚህ ሴኩዌንሳችን therefore our sequence is bounded between 1 and 3 ማለት ነው። ስለዚህ we can say that 1 is less than or equals to sequence 3n minus 2 over n is less than 3። በሌላ አባባል ይህንኑ ጥያቄ ደግሞ በቀላሉ የምንሰራበት መተድ አለ። እሱ ምንድነው? ጊዜ ሲሰሩ እንደዚህ አይነት አሁን ለምሳሌ ፖሊኖሚያል ኦቨር ፖሊኖሚያል የሆነ ኤክስፕሬሽን ከሆነ for any variable let's say እዚህ ጋር n ሆነ xም any ሌላም ሊሆን ይችላል። ሁልጊዜ ምንድነው የምታደርጉት? highest degree of the polynomial ሁለቱንም ኤክስፕሬሽኖች ማካፈል። እዚህ ጋር አሁን ለምሳሌ እዚህ እናካፍልና n ነው አሁን highest ዲግሪው። ስለዚህ ሁሉንም ኦቨር n ማለት 3n over n minus 2 over n over n over n። ይሄን ካያችሁ ምንድነው 3 here ይሄ ጣፋል እዚህ ጋር ጣፋል። ስለዚህ ምን ይሆናል? 3 minus 2 over n over 1 ማለት ነው። ስለዚህ የኤናችን ቫልዩ የጨመረ ቁጥር ይሄ ቁጥር ወደ 0 ነው አፕሮች የሚያደርገው። ኤናችን ለምሳሌ ይሄ በጣም ትልቅ ቁጥር ነው። 2 over ለምሳሌ 100 ብንል 2 over 100 2 over 1000 ብናደርገው ይሄ ቁጥር ኦልሞስት 0 ማለት ነው። ስለዚህ ይሄ በሌላ አባባል ምን ይሆናል ማለት ነው? 3 minus 0 over 1 which is 3። ስለዚህ ይሄ ሲኩዌንስ ወዴት ኮንቨርጅ ያደርጋል ማለት ነው? ወደ ማን አፕሮች ያደርጋል? ወደ 3 አፕሮች ያደርጋል ማለት ነው። ስለዚህ ኦሬዲ የመጀመሪያውን ተርም ሰብስቲት አድርገን for n is equals to 1 ሎወር ባውንዳችን እናውቃለን። ይህ ሜተድ ደግሞ ተጠቅመን አፐር ባውንዱን አይደንቲፋይ ማድረግ እንችላለን ማለት ነው። I hope you are finding this lesson interesting። እንግዲህ ሁሌም እንደምላችሁ keep practicing. Thank you. Limits of sequence. Example 3, consider the terms of the sequence. The sequence 1 over n for n an element of solution. Here some of the terms of the sequence 1 over n are for n is equals to 1 1 over 1 is 1, for n is equals to 2 1 it will be 1 over 2, for n is equals to 3 it will be 1 over 3 and so on. As you can see, it's clear that as the value of n becomes larger and larger, the nth term 1 over n of the sequence become smaller and smaller, hence it becomes very very closer to 0. In this case 0 is said to be the limit of the sequence 1 over n, and we can express this as the limit of 1 over n as n approach to infinity is 0. Therefore you can read this as the limit of 1 over n as n approach to infinity is 0. That means as the value of n increases, the value of 1 over n is very closer to 0. Generally note that for the sequence c plus 1 over n, this sequence converges to c where c is a constant. For example, you can take the sequence 5 plus 1 over n. As you can see from the expression, this sequence converges to 5 as the value of n gets larger and larger. The value of 1 over n will converge. That means the terms of the sequence 1 over n are getting smaller and smaller, and which is converged to 0. Therefore we can say that the limit as n tends to infinity of 5 plus 1 over n is 5. Here is a theorem: let an and bn be convergent sequence with the limit as n tends to infinity of an is L, and the limit as n tends to infinity of bn is m. Then the sum that is the sequence n plus n, and the difference the sequence n minus bn, and a constant multiple c times an, and the product an times bn, and the quotient an over bn, provided that m is different from 0 and bn is different from 0 for every n are convergent with, that is the first is called the sum rule, that is the limit as n tends to infinity of an plus bn. We can compute this as independently, that is the limit as n tends to infinity of an plus the limit as n tends to infinity of bn, that is because we have already said that the limit as n tends to infinity of an is L, and the limit as n tends to infinity of bn is m, therefore it is L plus m. And the same is true for the difference of n minus bn, that is the limit as n tends to infinity of an minus the limit as n tends to infinity of bn, that is L minus m. And the third one is the constant multiple, that is the limit as n tends to infinity of a constant c times an can be written as, you can take out the constant and c times the limit as n tends to infinity of an, that is c times L for a constant c. And for this product rule, that is the limit as n tends to infinity of an times bn, the product of two sequence will be the limit as n tends to infinity of an times the limit as n tends to infinity of bn, which is L times m. And lastly, we have the quotient of the two limits, that is the quotient of the two limits n and bn will be the limit as n tends to infinity of an over the limit as n tends to infinity of bn, that is L over m. And lastly, if an is greater than or equals to 0, as n tends to infinity, the limit as n tends to infinity of the square root of an can be written as or equals to the square root of the limit as n tends to infinity of an, which is the square root of L. Okay, example 5, evaluate the limit as n tends to infinity of n plus 1 the whole square over 2n square plus 3n plus 2. Here, in order to evaluate this limit, we need to apply the theorem which we are discussed earlier. Therefore, in order to evaluate this limit, first we need to express this term is a product of this expression is a product of two terms. Therefore, we need to express that. Therefore, this means the limit as n tends to infinity of n plus 1 square means it's the same as n plus 1 times n plus 1 over 2n square plus 3n plus 2. And this is the same as, we can write this as, this is the limit as n tends to infinity of, here n is multiplied with the whole expression n times n plus 1 times 1 times n plus 1, that is n plus 1, that is n plus 1. And here this expression has to multiply it the whole over 2n square plus 3n plus 2. And this is the same as n times n is n square and n times 1 is n. Therefore, this expression will be, this expression is converted into n square plus n, and therefore here is n square plus n. This is the limit as n tends to infinity of n square plus n plus n plus 1 plus n plus 1 the whole over 3 to n square plus 3n plus 2. And this expression is the same as the limit as n tends to infinity of, here we can add these two terms, therefore n plus n is 2n, therefore this is the same as n square plus 2n plus 1 over 2n square plus 3n plus 1. As we have discussed earlier, if we have such type of expression, that is, if you have an expression like polynomial over polynomial, we need to divide each expression by the highest degree of the polynomial. Therefore, we have here n square, n, and n. Therefore, n square is the highest degree of polynomial. Therefore, we need to divide each expression by n square. This means the limit as n tends to infinity of n square over n square plus 2n over n square plus 1 over n square, the whole over the limit as n tends to infinity of, here we can apply the quotient rule, that is 2n square over n square plus 3n over n square plus 1 over n square. As you can see from here, we can cancel out this one, n square, and again this one, and finally we have here, this means this one is 1, again this is, we are remaining with 2. Therefore we can write this as the limit as n tends to infinity of 1 plus 2 over n plus 1 over n square over the limit as n tends to infinity of 2 plus 3 over n plus 2 over n square. And therefore this is the same as here. We know that the limit of a constant is the constant itself, therefore we can write the above expression as the limit as n tends to infinity of, here, of 1 plus, since this limit is 0, we have the limit as n tends to infinity of over 0 is here each individual limit, the limit of a constant is the constant itself, therefore we can write this as this limit is 1, the limit as n tends to infinity of this one is 0, 2 over n, as n tends to infinity, 2 over n approach to 0, plus, again the same is true, as n tends to infinity of 1 over n square approach to 0, and again the limit of this one, the limit of a constant function is the constant itself, and this limit is as n tends to infinity or getting larger and larger, this limit approach to 0. The same is true for this one, 2 over n square will approach 0, therefore this is the same as 1 over 2. Therefore we can say that therefore the limit as n tends to infinity of n plus 1 square, the whole square, over 2n square plus 3n plus 2 equals to 1 over